Carbon in its various forms. Carbon is the 17th most abundant element in Earth's crust. It forms more compounds than any other element except hydrogen. It is widely distributed in nature, both in free and combined state. In its free state, it occurs as diamond, graphite, like the tip of a pencil, and coal. In the combined state, carbon occurs as carbonates present in many minerals. Example of minerals containing carbonates include CaCO3 MgCO3 or dolomite, CuCO3 CuOH2 malachite, FeCO3 siderite, and ZnCO3 calamine. These are just a few examples. The amount of carbon in Earth's atmosphere is present as carbon dioxide CO2, currently at a concentration of 428 parts per million. All living systems are made up of carbon compounds such as fats, carbohydrates, proteins, vitamins, hormones, nucleic acids, etc. Fossil fuels such as coal, petroleum, lignite, etc. are carbon compounds. Carbon is able to form a wide variety of compounds because it makes 4 covalent bonds. This characteristic is what makes carbon form chains, making up the compounds found in living systems. Life as we live today would have been impossible without carbon compounds. Carbon and its allotropes. Carbon exhibits allotropic modifications. An allotrope is a substance that can exist in different forms. These different forms have different structures and physical properties, but identical chemical properties. There are 2 types of allotropes for carbon: crystalline and amorphous. Crystalline allotropes have their particles arranged in an orderly, repeating structure. A unit cell is one piece of the structure that has the complete pattern in the arrangement of particles. Amorphous allotropes do not have an orderly arrangement of particles. Crystalline allotropic forms of carbon are diamond, graphite, and fullerenes. Amorphous allotropic forms of carbon are coal and charcoal. Due to different molecular structures, crystalline allotropes and amorphous allotropes have different properties. Diamond occurs in nature. Each carbon atom is sp3 hybridized, and it's connected to 4 other carbon atoms in the tetrahedral arrangement that you see here. It is not a conductor of electricity due to a lack of free electrons. It has a high refractive index at 2.5, and it can refract and reflect light. It is transparent. Refractive index measures the bending or refraction of light when it passes through a medium. Due to the covalent network structure, it is one of the hardest materials used for cutting tools and making abrasives. Graphite occurs in nature and can be manufactured artificially. Each carbon atom is sp2 hybridized and connected to 3 other carbon atoms. So if you look here, we have 1, 2, 3, 1, 2, 3. It forms a hexagonal ring layer structure with a 2-dimensional sheet, unlike in diamonds. So you see these layers that layer together like sheets. Since the 2 layers are connected by weak van der Waals attractions, which you see here, one layer can slip over the other, and it acts as a good lubricating material. The 4th valence electron is free to move. So there's only 3 bonds, and then there's a free electron, and as a result, graphite is a good conductor of electricity. It is opaque and has metallic luster. Fullerenes. This is a more recent structural form of carbon added to the allotrope list. It is formed when graphite is vaporized in the presence of an argon laser into soot. Its molecular structure has been identified as C60. It has a soccer ball-like structure, which you can see in the image, and is sometimes called a buckyball. Graphene and carbon nanotubes are also listed as new allotropes of carbon and being studied by scientists due to their exceptional properties in the nanotechnology field and in medicine. Carbon nanotubes are intermediate between fullerenes and graphene. They can be single-wall or multi-wall carbon hexagonal sheets formed into a hollow cylindrical tube. Multi-wall tubes are held together via van der Waals interactions. Graphene consists of a single layer of carbon atoms arranged in a hexagonal honeycomb lattice. Each carbon atom is connected to 3 other neighboring carbon atoms. The 4th valence electron on each carbon atom is free. This free electron imparts exceptional conducting and electronic properties. Amorphous allotropic forms, coal and charcoal. Of all of the allotropes, charcoal is the most reactive. Carbon and its compounds. Carbon and carbon compounds readily burn in air to form carbon dioxide, a carbon oxide. Carbon reacts with many metals to form carbides. With more electropositive metals, such as beryllium, magnesium, calcium, and aluminum, it forms ionic or salt-like carbides. There are 2 types of ionic or salt-like carbides. Beryllium carbide and aluminum carbide will produce methane gas when it undergoes hydrolysis with water, and these carbides are known as methanides. Magnesium carbide, calcium carbide, and barium carbide will produce acetylene gas when they undergo hydrolysis with water, and these carbides are known as acetylides. So in the first one, here's the aluminum carbide, which will produce methane gas, CH4, and then the calcium carbide, when undergoing hydrolysis, produces acetylene. Covalent carbides. These are carbides formed with less electropositive metals than carbon, such as transition metals, tungsten, zirconium, vanadium, and iron. Preparation of carbides. Carbides are usually prepared by heating carbon with the metal or its oxide at a very high temperature. Silicon carbide, SiC, and tungsten carbide, WC, are very hard and are used for polishing, drilling, and cutting tools. Boron carbide, B4C, is even harder than the silicon carbide and increasingly is being used as an abrasive, bulletproof vests, and radiation shields.